I'm going to make one more video from section 6.3, and everything in this will be going through questions from old AP tests. So all of these I found on the AP site, and I thought they were good examples of what you would have to do on an actual test. So the first one, I thought this one was kind of interesting because there's not really a lot of work associated with it. It's more just a basic understanding of what's happening here. So they give you a differential equation, this dy over dx equals x over y, but they don't ask you to solve it. Instead, they actually tell you what the general solution is. So they start telling you that the general solution is y equals plus or minus the square root of x squared plus c. They also give you an initial condition, and the question is which one of these answers could be a particular solution. So we have this general solution. We're making it a little more particular. So here's the first thing you want to look at. When we take a square root, we always put plus or minus. But what we've looked at is it's not going to be both the plus or the minus. You're going to have to use your given information to figure out which one. So if you look at your given information, your initial condition, your y value is negative, which means instead of wanting the positive square root, it actually wants the negative square root, which means it can't be b and it can't be d. So then the next piece is talking about the domain, which is not really something that we've talked about, but let me show you how easy this is to go through it. So your domain represents your x values. So we have two options. Either my x value is less than -3 or my absolute value of the x value is bigger than 3. Well, take a look at the actual x value in your problem. The x value in your problem is less than -3, which means that your answer is A. We won't really deal much with absolute value. Whenever you're working with these, you're going to be just looking at what is your given x value that you can plug in. All right, next one. This one you will have to actually go through the full process of separating and integrating. You do not have an extra piece of information to plug it in at the end, though. You do have an initial condition for the c value. So we're going to start by separating. So when we separate, the y squared is going to come on the left. So we're going to divide by y squared. The x is going to stay on the right, and the dx is going to join it. We're going to integrate each side. So you have a y squared in the bottom. That's a y to the -2. So power 1 greater divided by that power. X, you just have a plain old x, so power 1 greater divided by that power. You get -1 over y equals x squared over 2 plus c. I'm going to take my initial condition to find my c value, and then I'll take the time to get y by itself because you'll notice all 5 answers have y by itself. So when I put in 1 for y, I get -1 equals, when I put in 2 for x, I get 4 divided by 2 is 2 plus c. Subtract 2 on both sides, my c value is -3. So I have -1 over y equals x squared over 2 minus 3. Here's where your algebra knowledge is actually going to be more important than your calculus knowledge. I need to get everything on this right side into a single fraction so that I can then flip that fraction and set it equal to y. So when I do that, my common denominator will just be 2. So I'm going to have, instead of -3, it's going to be like -6 over 2. So here's how I would write it as one fraction, just getting everything to have a denominator of 2. Currently, that 3 has a denominator of 1. Now, it is perfectly legal to flip each side of my fraction. It's still negative, but now my 2 is on top, and I have an x squared minus 6 on the bottom. And then finally, I need to get rid of this negative, which means I need to multiply by a negative on the other side. So a couple ways to do that. You could put the negative in the top. However, that's not what they did. What they did instead is when they multiplied this by a negative, they actually just switched the order of the subtraction of the denominator, which is the same as multiplying by a negative. So your correct answer here is 2 over 6 minus x squared. I will say I would have eliminated a and b pretty quickly because we never had a natural log when we integrated, which means I would never have an e when I solved. E is a very, very, very similar answer, and I can see where that would come up. That would be the person that forgot to flip each side of the fraction. All right, this one's actually much easier. It looks like it's going to be harder, and I wanted to mention one of these. This is one where it is asking you to integrate and it gives you initial condition. But what I want you to realize is there is no need to separate this because everything that this derivative is written as is already in terms of x. I mean, you could bring this dx to the other side, kind of like a quick step that we do naturally. But because your derivative in terms of x is already in terms of x, we don't have that separation step that we normally do. So the integral of 2 sine x is negative 2 cosine x. That's probably the other challenging part, is keeping track of your pluses and minuses. You have your initial condition, so we're going to put 1 in for y and pi in for x. So the cosine of pi is negative 1. So you have a negative 1 times a negative 2, which gives you just a 2. Subtract 2 from both sides, we get our c value to be negative 1. So we're looking for a particular solution of negative 2 cosine x minus 1, which is right here. We could eliminate a and b because it had the wrong sign in front of cosine. And then c and d had the right initial piece, but it had the wrong c value. Last one, and I like giving you a chance to see one like this. This is an error analysis question. I feel like back in like maybe Algebra 1, you start looking at error analysis, basically looking and saying like, when does a mistake happen? So you're not actually going through and doing a problem. You're kind of looking at someone else's work, being like the teacher for a second and figuring out where did they mess up. So this one, it gives you this differential equation and an initial condition, and it lays out their work into steps. So when this is presented, it is a multiple choice question, and your choices are step 1, step 2, step 3, step 4, step 5. So basically, you're identifying when did they mess up. So my first step would be to separate, and if you look at step 1, that's exactly what they did, and they separated correctly, so no issue so far. Step 2 would be the integration step. The y side is the natural log of y, which was done correctly, and the x side is a power rule, so power 1 greater divided by that power. So far, so good. Step 2 to step 3 is going to be solve for y. So now when you solve for y, and this is the most common mistake, and that's exactly what they harp in on here. When you solve for y, you're going to exponentiate, which is going to give you y equals. However, this c is not plus at the end. It actually ends up becoming the coefficient of e because of our exponent rules. So this step 3 should actually be c e to the x squared over 2, which means this is when the error occurs in step 3. Now to go further, obviously their work from here on out is wrong, but to go further, you would plug in your x value and your y value into this equation to get your c value, and then that would give you a particular solution. I can show you what that looks like. So you would get 2 equals c e to the 0. E to the 0 is just 1, so you get c to be 2. So what the answer should be is it should be 2 e to the x squared over 2. So just in these 4 questions, you kind of see a variety of ways that questions can be asked. You can have ones that are kind of done for you and you're trying to interpret the answer like the first one we looked at. You can have an error analysis like this one, or you can have ones like the middle ones where you're going through the process of separating, integrating, and then finding your C value, but not going a step further to evaluate further.